Hi everyone, how are you doing? I hope you're having a lot of fun at the Go Further conference. I am Arpa and I'm excited to be here with you. Talking about fun, isn't it very nice outside these days in the spring weather? I know I love going outside and have fun, run around or walk or maybe even bike. Hope you're doing that too. But you know what? Sometimes I do get tired from all the running and walking, and I want my cold drink to be ready when I want it. And I do take my thermos with me to the park with cold water in it. But it does not always keep the water cold, just like I want it at my home. Do you also face the same problem? Wouldn't it be great to have your cold water cold for a very long time so you can forget about that and keep playing for a long time? So let's talk about how cool is your thermos and how can you design even a better one. So a little bit about myself before we talk about thermos. I am Arpa Ghosh. I am a scientist, postdoctoral research associate, and I work at this really nice building here, Bioeconomy Institute. I love playing with molecules because I am a chemical engineer, but I also love singing in my pastime. What's your favorite activity outside work? But you know what I love the most? I love hot chocolate and ice cream. Ooh, that's great. What's your favorite hot and cold drink? And wouldn't it be nice to keep your drink cold or hot all of the time, just like you wanted? A thermos does exactly that. A thermos helps keep the heat from entering or leaving the vessel. If you have noticed at your home, when you keep some cold water in the thermos or hot coffee in the thermos, it stays warm for a very long time. So we will learn today how to design such a thermos for keeping a cup of ice water cold. So let's talk about some science before we do that. We need to know what thermodynamics means before we can talk about thermos. Therm, the word means heat, and dynamics means movement. So thermodynamics means movement of the heat. Basically, we mean that thermal energy can be converted to and from other forms of energy. That's essentially thermodynamics. And when you have a high temperature object sit beside a cold temperature object, heat transfers from the hot to the cold temperature, and eventually they come to the same temperature, and therefore no more heat transfer happens between the two objects. And this is when we call that an equilibrium has reached. When you cook something or boil water on the stove, you will see that the water starts to boil after some time and there is heat transfer going on. But after some time, there is no more heat transfer. So we have equilibrium. And a thermometer helps us understand how hot and how cold an object is because it measures temperature. So we will use all of these concepts in designing a thermos. So let's get to work. Let's design a thermos of our own. For this, we need to understand what is insulation. Insulation is nothing but a material that kind of wraps around something to keep the heat from entering or leaving. So if you have a cup plastic cup at home and you wrap that with a paper or bubble wrap or styrofoam, you are making it insulation around the cup. So we will do something like that today for making the thermos. We will take 3 cups and do our experiments. The first cup will be no thermos cup, that is, it has no wrapping, no insulation. And this will be our control thermos. So we will do all our other insulation or thermos based on this design. The second one will have a paper towel wrapped around it, and we will call it the paper towel cup. And the third one will be an aluminum foil with aluminum foil wrapping around the plastic cup. All these cups are of the same size. Now, how do we make a wrapping? How do we make an insulation? First, let's get some paper towel for our paper towel cup. And then from the edges, let's fold that paper towel. And here I have taken 4 turns of folds. And then we just simply wrap around the cup and use some tape and scissors to close it. We will keep the top of the cup still open. We will do the same exact type of wrapping for our aluminum foil, and you can even do another cup with some other insulation like bubble wrap or styrofoam, etc. So now we have our thermos cups ready for experiment. Are you ready for experiment? Let's jump into it. So the first thing we will do is get some ice water ready on the side. And as soon as all of the ice has melted in the water, we will pour equal amount of ice water in each of the cup. And then we will be ready to start our experiment. So as you can see in this picture, we have taken some ice water with melted ice in each of our cups with different insulation. You can also try out some other favorite cold drinks of yours, like maybe orange juice, etc. for this experiment. The next step is to use a thermometer and dip that in the first cup, that is no thermos, and we will record the temperature. As you can see, this long thing in here is the thermometer, and it has some scales that you need to read to understand how hot or cold the water is. And as you can see, the tip of the thermometer stays all the way inside the water. And the blue line in here moves up or down as the temperature increases or goes down. For ice water, I found that my cold water in the thermos cups, all of the thermos cups, were close to 4 degrees Celsius. So this is our starting temperature for all the cups. And now we are going to set timer for 5 minutes and wait and see how the temperature changes in each of the cups. We perform the same experiment for paper towel cup and the aluminum foil cups. You can use either one thermometer and repeat the same experiment for 5 minutes in the rest of your cups, or you can just get 3 thermometers if you can, and then put them together in separate cups and measure the temperature after 5 minutes over. After 5 minutes, we want to see which thermometer was best at keeping the ice water cold for the longest time. How do we do that? The first question we need to ask is the final temperature same in all of the cups? what is the difference between starting temperature and final temperature in each of the cup. And the best thermos will be the one that shows least of the temperature increase, meaning that each thermos with different types of insulation or no insulation will get warmed up after some time. But the one that has the best insulation, that is the best thermos design, will not let the water get hot. And from my own experiment, the winner thermos is, first we see that the no thermos had the largest increase. It increased the temperature of the cold water by 1.5, that is 1.5 degrees centigrade. The second was pretty good. The paper towel performed pretty good, and it only let the water get warmed up by 1 degree Celsius, and that is less than having no thermos. So paper towel is better than having no insulation at all. But you know which one was the coolest thermos? It was the aluminum foil, because it only raised the temperature by half, 0.5 degrees Celsius. So clearly our winner was coolest thermos, aluminum foil cup. Now, do you know why aluminum foil cup was the best and paper cup was not so close to aluminum foil? It's because although paper cup and aluminum foil, both of them were good or better than having no insulation, they were able to store the heat, and they were not letting the heat go outside of the cup. But aluminum foil is a better insulator because it has a shiny surface. So when light and heat energy drops onto the surface of aluminum foil, it gets reflected, it gets jumped back. And so that way the cup does not get hot. Paper towel on the other side has a lot of air pockets, and that helps keep the heat from getting inside the cup. But it's not as good as the aluminum cup. In nature, you will find a lot of different materials that can be maybe even better than aluminum cup. You can try your own design, like with bubble wrap or styrofoam, and see which one design is the best at keeping cold water cold. So, you can even be an engineer in the future and make all the cooling and heating easy for yourself and for everyone. Do you like designing a thermos? Do you know that you can be a chemical engineer just like me and design insulation materials for keeping the house warm and so on? Do you know that you can even design very cool suits to keep astronauts warm in the space? Wow, wouldn't that be so nice? And you can be the coolest engineer. So with that, think about different ways of making your thermos cool and cooler than others, and have fun. Thank you so much for watching. I hope you have a nice time at the conference.